Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through 2 parallel lines, which are our 2 north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the 2 angles are alternate, they're z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on. Because 5 bus stops with X passengers. So that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less. And the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got x on both sides, so we look at the x's. We've got 12x and 6x, so we always take away the smaller amount. So we're going to take away the 6x both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got x is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for x? Now, it is tempting to write down 10, but it says x has to be less than 10. So the biggest number we can get that is less than 10 is 9. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So we're timesing them. So 10 times 10t, 10 times 10 is 100. So it'd be 100t. 10 times 4 is 40. So our answer will be 100t plus 40. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chelton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chelton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chelton at 9 o'clock. He drives from Chelton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay. Now, having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time. And we're covering up the time, because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it will be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says to expand your answer fully, so we're just going to expand the brackets. 7m plus 70. There are two rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now this red line does not go through the origin, so A and B cannot be in direct proportion. So I'm going to start off just with a quick sketch, and we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them. And let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here. And we know that this angle here will also be 85 degrees because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles. And we know that this angle here is going to be 180 degrees because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an X and this a Y and written X equals 85 and Y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. We know that when you multiply powers with the same base, and here we've got all these as base V, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So W therefore equals 4. To find out what the value of X is, we first of all have to find out what the value of Y is. And we can notice that we've got two sets of parallel lines here and here, and a line going through them. And we kind of got these F angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. The first thing to notice is that the tree must be closer to CD than AB. So if we draw a line across the middle, it can't be in the top bit because that would be closer to line AB. The second piece of information that is given to us is it must be at least 11 meters away from point C. So we get our compass out and measure 11 centimeters, or whatever the scale we're using in this diagram is, and we draw a quarter circle from C. And it says shade the region that it can be planted. So this is the region that represents closer to line CD than AB, but also not within 11 meters of point C. So to find the gradient, we need the formula, or the equation, in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6, because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets. So that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that'll be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30, and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by minus 3, because they're minusing 3 each time. So we know that the number before the n is going to be minus 3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3, and we would find it to be 20. So whatever numbers our 0th term, because 17 is our first term, is going to be what we add to the minus 3n. So it's going to be add 20. So our answer is minus 3n plus 20. So the distance initially travelled is going to be 14 kilometres for this stint here. And then we have a bit of a rest. A horizontal and distance time graph is essentially stopped. But then here we start up again to go home. And so that's another 14 kilometres travelled. So in total, there has been 28 kilometres travelled. I'm going to write this out just a bit bigger so we can see what's going on. And there are loads of different methods for expanding brackets. I'm going to use smile and rainbows. So smile there, rainbow there, and I always put a little notch here to remind me to times it. So we're going to do 4 times 8, which is 32. And x times x, which is x squared. Then we're going to do 4 times 3, which is 12, and x is just there. So when we expand that, we get 32x squared plus 12x. To find the gradient, we need to first of all find 2 coordinates we know. So I'm going to pick this one and this one. And to find the gradient, we're just going to draw a right angle triangle between them. And the gradient is the change in y over the change in x. But here you can see that we've gone down 3. So it's a negative 3. It's gone down 3. And we've gone 1 to the right. So that's going to be minus 3 over 1, or just minus 3. So the gradient, a different definition of it is how far up we go when we go 1 to the right. So here we've gone 3 down, so it's going to be -3. To find the error interval, I start by just drawing a number line, and we're going to put the number in, so 50.14. And we're going to think to ourselves, well, what would the next number down and the next number up be? Well, it's the nearest hundredth of a gram, so the next number down would be 50.13, and the next number up would be 50.15. Then to find the lower bound and the upper bound, or the highest and lowest it could be, we just find the halfway points between those two. And so the halfway point here is 50.135, and the halfway point here would be 50.145. So the lowest it could be is 50.135, the highest it can be is 50.145, and it asks us to use W for the weight, and we're going to show this with inequalities. Now it can be 50.135, so it's larger than or equal to 50.135, but it can't be 50.145 exactly, otherwise it would round to 50.15, so we don't put the line underneath the inequality. So we're going to start by doing a grid, a multiplication grid, and we're going to start by putting 2x plus 11 at the top and 5x plus 3 down the side. And we're going to multiply them out, so 5 times 2 is 10, so it would be 10x squared. 5x times 11, so 5 times 11 is 55, so it would be 55x, and it's positive. And 3 times 2 is 6, so it would be 6x, and that's positive. And 3 times 11 is 33, and that would be a positive. So when we put them all together, we get 10x squared plus 55x plus 6x plus 33. You can see that the x terms are like terms, so we can add them together. So we get 10x squared plus 61x plus 33. So our answer will be 10x squared plus 61x plus 33. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labeling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent. So we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two. So it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in. And we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29. And we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that in the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79. And that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves, so we'll have green on the left and brown on the right, so green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, that will be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8, and 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. I'm going to first of all draw the two triangles out separately. And we've got A, B, C, and then A, D, E. And the first thing to notice is we have similar triangles here, and the way we know that is that we've got an F angle here, which means they're corresponding on the two parallel sides, so these two angles are the same. Got exactly the same thing on this side, we've got F angles, so these two are corresponding, and then the top angle is shared between the two triangles. And when you've got two triangles with exactly the same angles, they are going to be similar, which means one's an enlargement of the other. I'm just going to put on the length that we've got. Now we're looking for quite a complicated one. We're looking for the length CE, which is this one here. Now I can't actually label that onto my two triangles, but what I do know is that CE is equal to AE minus AC. Now we know what AE is, which is 60. So we just need to find out what AC is, this one here. And when we find out what AC is, we can just take them away to work out what the CE is. So we need two corresponding lengths that we know both of them. So we've got the 9 and 36 here. Because these two triangles are similar, we know that we can work out what the scale factor is. And to work out the scale factor, you do big divided by small. So 36 divided by 9. And we work out that that is going to be 4. So we know we're going to have a scale factor of 4. So to get from the smaller triangle to the big one, we times it by 4. But here we have the one, we need to find out what this one is. So one corresponding is this one. We're going from the big to the small. And so to work out from the big to the small, we've got to divide it by the scale factor. So divide it by 4. So 60 divided by 4 is 15. So we know what this one is. So AC is 15. And so we're going to do AE, which is 60. Take away the 15. And that will tell us what CE is, which is 45. So our answer is 45. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7 over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1. And I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11. So we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. I'm going to start off by labeling this triangle. So we've got a big A, big B, big C, and the opposite ones are little a, little b, and little c. And we've got to figure out whether we're using the cosine rule, sine rule, or something else. We've got 3 lengths, and we're looking for an angle. So whenever we've got 3 lengths and an angle involved in the question, it's definitely going to be the cosine rule. And we've got to figure out which of the cosine rules we're using, because there's 2 variants, one when you're looking for a length and one when you're looking for an angle. And we're clearly here looking for an angle. So the cosine rule I'm going to use is cos A equals b squared plus c squared minus a squared over 2bc. And all that is, if you don't know what this formula is, it's just a rearranged variant of the a squared equals. So it's just rearranged, and it helps if you remember both of the formulas for the cosine rule. It does make things a bit easier. So we're going to write it again, but this time with all of the numbers and letters in that are in the question. So instead of b squared, we've got 9 squared plus, and then the c squared is 6 squared minus the 4 squared over 2 times b, which is 9, times c, which is 6. And when you do that on the calculator, you get 0.935 blah blah blah, but that's what cos x equals. So if we try and solve that now, all we need to do to both sides is the inverse cos. So we're just going to do the inverse cos of 0.935 etc. that's on the calculator, and that gives us 20.741 blah blah blah, and it says it wants its 2 decimal places, so that's going to be 20.74. So we're told in the question that y is inversely proportional to the cube of x, so we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now, to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed, and all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, well, y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'd be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now, so it's y equals 3,430 over x cubed, and that actually is our answer. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagrams 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference. And the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13 and the 66, and the reason being the same as before, so angles in quadrilateral add up to 360 degrees, and when you do that you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So we first of all need to work out the frequencies in each of the bars, and we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total. And they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, So we can just round that to 11. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA. And we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27. And then 12 over 26. And so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together, and when you add them together you get 234 over 702. Now I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. So we're going to need to complete the square to be able to answer this question, but the first thing I need to focus on is this 2, the coefficient of the x squared. I want to make sure that x squared doesn't have a coefficient, or has a coefficient of 1. So we're going to start off by just removing or dividing out that 2, and we're going to do it from the x squared and the x term. So we're going to be left with the x squared plus, and that's 14x. And we just leave this plus 5 at the end. Plus 5 really only ever comes into use at the end. Now we're going to complete the square here. So that will give us brackets x plus half of the x coefficient, which is 7 squared. And I'm just going to expand that quickly here. So x plus 7 squared is the same as x plus 7, x plus 7. And when we expand that, we get x squared plus 14x, which is good. And then we get plus 49. Now this bit here is the bit we need to remove. So what I'm going to do here is just take away that 49, because we don't really want that 49. Close bracket, plus 5. Okay, now I'm going to expand these brackets and have the 2 next to the x plus 7 squared. And 2 times minus 49, which will be minus 98, plus 5. And then all we need to do now is add the minus 98 and the plus 5 together, which should be minus 93. The m part will be the 2, the p part will be the 7, and the q part will be the minus 93. With this question, we're going to first of all have to find a length before we can find the length AF, and it does involve us thinking in 3D. What I find sometimes useful though is to draw kind of a 2D representation of the 3D. So I'm going to look at this triangle here, and I'm going to notice that I need to find length BF. That's going to be my objective at the start of this. So I'm just going to draw out this triangle again, but in 2D just to make it a bit easier. And BF is this length here, this is 6, and then this is 9. So we're going to use Pythagoras, so it will be sort of a squared plus b squared equals c squared, so it would be 6 squared plus 9 squared equals bf squared. 6 squared plus 9 squared is 117. And then we just get our solving bit in, just to square root both sides. And I can leave this as square root 117 for now. Okay, the actual length that we want is AF, which is this one here. And I'm going to create the right angle triangle using this bit here. So let's just draw that out. Now the top bit is AB, which is the same as the bottom. It's going to be 14. It's going to be the same as EF. Then the BF we've just found is root 117, and we're looking for AF. And this is the right angle. I didn't show the right angle on the other one, but it should be there. Okay, so we're going to use our a squared plus b squared equals c squared. And a squared is 14 squared plus square root of 117 squared equals AF squared. So 14 squared is going to be 196. Now root 117 squared is just going to get rid of the square root, so it's just going to be 117. And when you add them together you get 313. And again get our solving lines in. Square root both sides. And this time we're actually going to square root 313 because we need a decimal answer. So it would be 17.691 blah blah blah. It's equal to AF. And it says to 2 decimal places, so that's going to be 17.69 centimetres. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, and I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put like notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now, if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be b to a plus a to m. We know b to a because it's labelled, it's just a. And we know a to m because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 a plus 1/5 b. And so a minus 1/5 a is going to be 4/5 a. And then we've got the 1/5 b. So it's going to be 4/5 a plus 1/5 b. So the first thing we need to realise is that we can create a right angle triangle from within this cone. So if I draw a line from the top going downwards, a line to the right and a line up, and we can label the sides. So we've got 30 here, and we've got 10 at the bottom here, and we're looking for this angle here, which we're going to call y. And if I just highlight all of this and move it across, then we're obviously going to be using trigonometry to find out what y is. So first step with trigonometry is, well, find out where the right angle is, which is there. And the one opposite the right angle is the hypotenuse. The one opposite the marked angle is the opposite. And the one between the right angle and the marked angle is the adjacent. In this question, we're not using the hypotenuse because there's no letter or number next to it. And so I'm going to do my SOHCAHTOA, SOHCAHTOA, and we're not using the H, so we're going to cross out these two. We're using the TOA, and that stands for tan the angle, which in this case is y, equals the opposite, which is 10, over the adjacent, which is 30. And so tan, so we're going to inverse tan both sides, so we're going to have to solve this. So let's get my lines in. And we're going to inverse tan both sides. So that will just leave y on the left hand side, and then we need to find out what the inverse tan of a third is. And the inverse tan of a third is 18.434 blah blah blah. Now, what I did at the start was I moved the diagram away from the cone. Let's just move it back and we'll see the fact that y is exactly half of x, because we've done a line straight down the middle. So to find out what x is, all we need to do is double y. So x is going to be 2 times y. So that's going to be 2 times the 18.434 blah 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 blah. And so that is going to be 36.869, etc. And it says it wants it to correct 2 decimal places, so that's going to be 36.87 degrees. So we have the original y equals fx shown in the graph, and it says it has a minimum at 1 minus 1, so it's this one is the black line here. And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.